Hello students, welcome to July's second lesson on residuals. Um, we're going to use our last lesson today to find residuals, and as a reminder of our last lesson, okay, here it is. We have to draw a line of best fit, okay, and our line of best fit is this one here. We'll talk about that in a second, but just a reminder, okay, we're going to use the exact same table. Again, they survey 12 students and they ask them how many hours you study per week and then what is their GPA, and this is their table right here. Okay, so just a reminder. So we're going to use this table to find residuals. Okay. All right, so again, we're going to find residuals. Okay, so find a residual of 0.10, comma 4.6. What does that mean? That means the student, we can use this student here. This student studied 10 hours and his GPA or her GPA is 4.5. Okay. So what is a residual? Residual is that when you take this graph right over here, okay, and again, and is that student 10 and 4.5? So this student right over here, okay, we want to find his residual. This is our line of best fit. And a residual is the distance between this person here, 10 hours and 4.6 GPA. Okay, and what is this distance from here to the line of best fit? So what is this distance right there? What is that distance right there? Okay, so to do that, okay, they have some sort of formula. Okay, to find a residual, you need to find the actual y value, okay, minus the predicted value. The predicted y value. Okay, so what does that mean? That sounds really confusing. Okay, so what does that actually mean? That means that we're gonna take this point here, which is x is 10, the 10 hours, and the 4.6 is the GPA. That is our x and our y on that point. Okay, on that point there, that's our x and our y. Okay, so that point represents 10 and 4.6. Okay, so the actual y value is actually this one here, 4.6. All right, the predicted value is that when you take our equation, and as you remember, this is our equation from last time, y is equal to 2.02. It might be 2.03, but anyway, they use 2.02, that's fine. So this is our equation, here. This is where it starts, 2.02, and this is the slope. Okay, so we're going to use that equation to find our predicted y value. All right, so again, so now we're going to plug in this x in here into this equation right over here. All right, so I'm going to do that right now, and I'm going to use a calculator to speed things up. Okay, quickly. So y is equal to 2.02x plus 0.17, and I'm going to plug in 10 in there. Okay, so that will give me y is equal to 2.02x plus times 10 would be 1.7. Okay, oh, my bad. This one here is no x, my bad. The x is over there. What am I doing? Okay, but anyway, so there you go. And then you add those two. So y is equal to, this will give me 3.72. Okay, so that is my predicted y value. Okay, and my actual y value is 4.6. So all I have to do now is just subtract those two. 4.6 minus, and then my residual, and then 3.72. Okay, so I'm going to go ahead and subtract those two. So I'm going to get 4.6 minus 3.72. Okay, so my residual is 0.88. So for this one here, my residual is residuals, oops, 0.88. So what does that mean? That means that this line over here is 0.88. So the distance between the actual line of best fit with the actual person is 0.88. Any question on that one? Go ahead and email me and let me know, okay? All right, let's move on to our question 2, okay? Now, they actually want you to write an equation for the upper and lower boundary lines, and then they want you to graph it, okay? So what does that actually mean? That just means that they want you to draw 2 more lines that is parallel to this line here, okay? Now to do that, you have to find the point, because you don't want the parallel line to go underneath those graphs. So they want you to go the furthest one out, okay? And then they want you to ignore this outlier right over here. Okay, so forget it. That's just way too far. all right? So it looks to me that this guy right there looks like it's the farthest, okay? Which is 7 and 2.2, okay? So 7 and 2.2. So right over here, all right? So let's go and find his residual really fast, okay? So again, we're gonna take 7 and 2.2 and then we're gonna find a residual. Okay, so we're gonna do the exact same thing. Okay, this is my x and that is my y. So for my residual, okay, I'm gonna go ahead and take well, this is 2.2. Okay, and I'm gonna subtract that by the equation. And just a reminder what the equation was, it's y is equal to 2.02 plus 0.17x, and our x happens to be 7, so y is equal to 2.02 plus 0.17 times 7. Again, I'm gonna take my calculator to speed things up. 0.17 times 7, that would give me y is equal to 2.02 plus 1.19 plus 2.02, that would give me 3.21, so 3.21. All right, now I'm gonna subtract those two. I know it's gonna be a negative, 2.2 minus 3.21. That would give me 1.01. So my residual for this guy, obviously he is missing because anyway, it's a negative 1.01. All right, so this guy over here, the 7, obviously you can see he's below. So this distance right over there, the distance that we just used is negative 1.01. So from here to here is 1.01. All right. All right, now we're gonna graph that. So I'm gonna take this one back real fast. But you know what? Let's go and write down an equation first. Okay, so we're gonna use the exact. We want it to be the exact same thing. So we're gonna use the exact same slope. So our slope is 0.17. Now you want to graph. So he's starting over here at 2.02. So you want to do like from the residual, you want to go up 1.01. So from here, go up to 1.01. So that will give you, because you start over here, you see that? Our original equations here. So we're going to actually go up there from 1.01. So I'm going to add that by 1.01. And I'm going to subtract that by 1.01. Okay? All right? So why don't we go ahead and do it? So my upper bound, okay, my equation is going to be, again, I'm starting at 2.02 from my original graph, 2.02, and I want to go up by the residual we just found, 1.01. So I'm going to add these two together. So I'm going to add those two together real fast. 2.02 plus the residual we just did, 1.01. That would give me 3.03. So my upper bound is 3.03 plus the same slope, 0.17, and an x. All right, now let's go and find our lower bound. All right, again, I'm going to subtract because now this one is 2.02. I want to go down 1.01, so I'm going to just subtract these two. So now I'm going to subtract those two, okay? 2.02 minus 1.01, that would give me 1.01. So 1.01 plus 0.17x. I know it sounds really confusing, but hopefully you already done this one. All right, now we're going to graph this. When you graph this, it's actually kind of tricky. You want to make it parallel, okay? So I'm going to graph the first one right over here. Okay, so 3.03 is somewhere over here. Okay, now I'm gonna use that 3.03. I'm gonna draw a line that is gonna look parallel to this one. I know it's a little bit tricky, but you kind of just want to eyeball it real fast and say, okay, you know what? That looks like it's parallel. Okay, draw my line. All right. Oops, they actually want you to draw a dotted line. My bad. That's why I use a pencil. All right. Now I'm going to do the same thing as 1.01 over here. So 1.01 is really close to 1. Okay, so somewhere over there. And I want to draw a dotted line. Don't make the same mistake as me. All right, there you go. And that's my upper and lower boundary lines, all right? All right, now let's go and move on to our last example. All right, now they want you to predict the lower bound. We're gonna use the lower boundary line to predict if a person was to study 8 hours. Okay, and all you have to do is just so our lower boundary line. Okay, our lower boundary line is right over here. All right, and 8 hours. So we'll find 8 hours, and our lower boundary line is over here. Okay. And now what we need to do though is plug in an 8 in here. So I'm going to do that right now. Y is equal to 1.01 plus 0.17 times 8. Again, I'm going to use the calculator to speed things up. So 0.17 times 8 plus 1.01. So my lower boundary line is going to be Y is equal to 2.37. And this is the GPA. Okay, now let's go ahead and find our upper boundary line. Again, same thing, our upper boundary line for 8 is over here. As you can see, is over here. All right, so this is the distance right there. But anyway, let's go ahead and do that real fast. Y is equal to 3.03 plus 0.17 and 8. Same thing, real fast. So 0.17 times 8 plus 3.03, that would give me 4.39. So our Y is equal to 4.39. So what does that mean? That means our upper and lower boundary line, okay, has a range of these two numbers there. So our GPA range from here to here is 4.39. That's a huge gap. So what does that mean? That just means that, you know what, looking at this data right here, and then seeing that this one here for the lower and upper boundary line is from 2.37 to 4.39, it's probably not a very good graph. It's not a very good line. It's probably very unreliable, okay? Because look at the gap between the GPA. So that just means that a person that studied 8 hours has a gap of 2.37 to 4.39. That means they can, you know, be an A student or a C student. It doesn't really say much about this graph. So therefore, it's just an unreliable source of data that we have here. The more you survey, the more you look at things, it'll probably be more of a easier line to look at. But you know, for now, it's just not a reliable source of data. All right. You're gonna do two problems very similar, so I expect to see two graphs and two of the same thing. You can research how to do this also and ask me any questions. All right. Thank you and have a great day and happy 4th of July.